Our bodies are not very efficient at using oxygen. They only manage to use 20% as energy for the muscles, and 80% is turned into the waste product, heat. Heat dissipates through sweat, and this leads to dehydration, which leads to fatigue because water is so vital for our bodies to be able to exercise. Hydration is important in energy production because 83% of your body is made up of water, and this helps to carry oxygen to your muscles for respiration. As you dehydrate and your blood thickens, it becomes sticky and less viscous. This stops the oxygen and nutrients getting to the muscles as efficiently. Most heat dissipates, but if you are exercising at high intensities, or the environmental temperature and/or humidity go up, your core temperature can increase enough to cause hypothermia, which leads to fatigue and in extreme cases, death. Nybo and Seisha 2004, Todd et al. In 2005 said, hypothermia can affect both central and peripheral processes involved in the production of muscle force and power. As we dehydrate, we lose weight, and this causes fatigue, which affects our sporting performance. When we have lost 5% of our weight, we have a 20 to 30% decrease in strength and anaerobic power. At 6%, we experience cramp, which means that we cannot continue to exercise. At 10% weight loss, we can experience circulatory collapse with aerobic performance. The graph shows that when we are well hydrated, our aerobic and anaerobic performance is 100%. When we are minimally hydrated, our anaerobic performance decreases dramatically by 45%, but our aerobic performance only decreases by 3%. When we are significantly dehydrated, our aerobic performance decreases dramatically by 55%. This graph shows just how important hydration is and what a big factor in fatigue it is. There are ways to prevent the impact of heat on our bodies. Heat acclimatization is where you train at the conditions you're going to be competing at. For instance, if you're going to compete in the Marathon des Sables in the Sahara Desert, you would train in a temperature chamber to help your body acclimatize. This means that when you are running, your body remembers that it has done this before. Pre-cooling, Gonzalez Alonso et al. 1999, is where you cool your body before exercise to help maximize performance. In high-level swimming galas, the athletes wait in a cool room before their event. They reduce their internal core temperature so it takes longer for heat to build up and affect their performance. Fluid ingestion, Hamilton et al. 1991. This is where you take in fluid before or during a sporting event. For instance, marathon runners and distance cyclists are given water as they race. Neuromuscular fatigue, depletion of acetylcholine, reduced calcium ion release, nerve impulse transmission. Depletion of acetylcholine. Acetylcholine is a neurotransmitter which is sent by the CNS to transfer the nerve impulse across the synaptic gap at the neuromuscular junction, which makes the muscle contract. It carries a message from the brain and the spinal cord to tell your muscles to move. If there is a depletion of acetylcholine, then the muscle cannot contract and fatigue occurs. Cholinesterase. Once the message has been sent, the enzyme cholinesterase, which is released in the muscle fiber, breaks down acetylcholine and prepares it to begin again. When there is too much acetylcholine, or not enough cholinesterase, then the action potentials cannot travel across the synaptic gap and fatigue occurs. Calcium ions are released to enable actin and myosin to attach. If calcium stores are reduced, actin and myosin cannot attach as often, and so there will be less muscular contractions or weaker muscular contractions. As we exercise, our muscles begin to leak calcium ions from the sarcoplasmic reticulum, and our muscle contractions stop being continuous. For example, as Chris Froome is cycling up his second mountain on a stage, of the Tour de France, his tired leg muscles begin to leak calcium ions, which reduces the power of his muscle contractions. When we exercise, we produce more hydrogen ions in the blood, which increases acidity and decreases pH. This causes a decrease in the conduction velocity and muscle fibers. This brings about a decrease in peak twitch tension and firing frequency of our nerve impulses. As a result of this, we experience a decrease in power in our muscles. Our fast twitch fibers fatigue very quickly, but our slow twitch fibers carry on for longer.